Hi, I'm Aaron Raw, Director of the Phylogeny Explorer Project. I'm going to try to explain cladistic phylogenetics. If you compare any two organisms, it's easy to see the differences between them, especially if we pick the two most distinct things we can think of, like a pine tree and an elephant, for example. They're both part of the same domain, eukarya, but they're about as different from each other as any two eukaryotes can be. If you only look at two species at a time, you'll always be able to tell the difference between them, like even between two elephants and two pine trees. But if you compare three or more species at once, then you'll notice that one of these things is not like the others, and two of these things are kind of the same. That's what Carolus Linnaeus noticed when he tried to systematically classify all living things. It wasn't just that some animals had legs or laid eggs or some didn't. It wasn't like you could just sort every organism into one or two umbrella kinds of life. It turned out to be way more complicated than that. And not just because of the number of horizontal categories, but the stack of vertical categories, wherein everything in two daughter sets within one parent group also belonged to a hierarchy of other boxes within boxes, like folders within folders. And some of the other things in boxes horizontally to the side also belong to the same top few boxes vertically. What Linnaeus discovered was a branching tree pattern that the notion of created kinds could not account for or explain away. Now, evolution does explain this, but Linnaeus didn't know about that because he lived 100 years before Darwin. To illustrate this another way, let's look back at the elephant and the pine tree and let's compare them to some other things, like a starfish, for example. Now, these things are all very different things still, aren't they? I mean, except for the elephant and the starfish both belong to the animal kingdom because they're both multicellular eukaryotes with an internal digestive system, while the pine tree belongs to kingdom Plantae because it has cell walls and chloroplast. People tend to be more interested in animals than plants because, we are animals. You are a multicellular eukaryote with an internal digestive system. That's what an animal is. So we'll stick with animals for the rest of this illustration and add a fish. And not a starfish because, just because you call it a starfish doesn't mean that it's a fish. To be a fish, it at least has to be a chordate. Even though all of these animals are very different, the fish and the elephant both belong to the phylum Chordata because they both have a spinal cord. And although you'll never see it, I'll bet you have a spinal cord too. And that means that you and the elephant are both fish. Well, except that fish doesn't really mean anything anymore because cladistic taxonomy has changed all the rules. A clade is a taxonomic grouping that includes every descendant of that group without exclusions, like all of these except for that. That would be paraphyletic. Cladistic classification is monophyletic, meaning every descendant, all of them, no exceptions. So either every chordate is a fish or none of them are. So the word fish could effectively mean chordate if it means anything in taxonomy. Now, some say it should be vertebrate instead of chordate, but whatever. Now let's throw in a lizard, any random lizard. There are like 6,000 species of lizards that are still alive today. That's not including those in the fossil record, and it's not counting snakes either, because snakes are lizards now too. That's part of the new way. Because if snakes used to be lizards, then they're still lizards now. But you know what are not lizards? Dinosaurs. Dinosaurs are terrible lizards because they were never lizards at all. And pterosaurs, which some people call dinosaur birds, are not dinosaurs. But birds are dinosaurs. And birds are the last surviving subset of dinosaurs because they evolved from dinosaurs, which means that they're technically reptiles just like lizards. Though they're not lizards, they're from a different group. Because the law of monophyly is that you can't grow out of your ancestry. A new species gets a new name, but not any of the higher taxonomic levels, which remain undefined. We just keep those names to use as signposts to keep from getting lost as we navigate the tree of life. And I know it's confusing, mixing colloquial and scientific terms, but if anything alive today was once a reptile, then it's still a reptile. But we were never reptiles, because that word doesn't mean what it used to either. Reptiles now referred only to sauropsids, not synapsids like us. So chickens are reptiles, but Dimetrodon is not, because it's more closely related to us than it is to any dinosaur. So looking at all of these, we can see that two of these things are kind of the same because they're vertebrates with backbones and they're tetrapods having 4 legs, as well as amniotes being born in amniotic fluid. But vertebrata, tetrapoda, and amniota didn't make it into Linnaeus's list of taxonomic ranks because that was too advanced for the 1700s. We've had to build the system up a bit since then. So we'll swap out the lizard for a mouse because elephants are supposed to be afraid of mice, or so they say, and there's a huge size difference, so these two got to be very different, right? except that they both belong to the mammalian class because they're warm-blooded, hairy, and they have mammary glands. And there's at least a 50-50 chance that you have mammary glands too, which means that people are mammals just like elephants. Except that people and elephants are in different taxonomic orders. So this is where our lineage and that of elephants diverge, at least according to Linnaeus's way too simplistic system. We are in the order of primates, whereas elephants are in the proboscidean order. Now, elephants might be the only things you can think of from that order because the rest went extinct a really long time ago. Things like Moriartherium, Gomphotherium, Dinotherium, Platybelodon, Tetrabelodon, Stegotetrabelodon, and Mastodon. They're obviously related to elephants, but they're not elephants. They're all in the same order, but not in the same family. Elephants are, of course, in the elephant family, Elephantidae, where everything in that family is an elephant, just like we are in the ape family, Hominoidea, where everything in our family is an ape, including you. There are several species of apes, including humans, and just like there are several species of elephant. Most of them are dead now too, like the woolly mammoth, Columbian mammoth, and the enormous Paleoloxodon, possibly the largest land mammal that has ever lived, much bigger than the 3 regular-sized elephants that we have left today, 2 African and 1 Asian. Now, Linnaeus classified everything by physical characteristics, so our taxonomic hierarchy was originally based only on morphology, wherein Linnaeus lamented that he was unable to tell humans apart from apes, and he classified us along with chimpanzees and orangutans as if we were essentially the same thing, because we are. Because now they've unlocked the genome, which proved that Linnaeus was right. And we don't just look like apes, we are apes genetically. And that fact meant that the deliberately, deceptively contrived taxonomy from the 1700s had to be revised and corrected. We now understand that an ape is any member of the taxonomic superfamily Hominoidea, and that includes humans. Although, some people object to that, imagining that evolution is supposed to teach that one kind of animal suddenly turned into another fundamentally different kind. But it's not like that at all, and it never was. In fact, that would violate the evolutionary laws of monophily and biodiversity. But it's easier to understand now that we can see that every taxonomic kind of thing your evolutionary ancestors ever were, you still are, even if you're also the start of something new. Comparing genetic orthologs, matching gene sequences, allows us to perform paternity tests, not just to see who your father was, but much further back, to also see who, or perhaps what, your great, so on and on grandfather was, and precisely how we and they are related to everyone else in humanity or everything else in the biosphere. The reason it's called phylogenetics is because of the inclusion or fusion of DNA into taxonomy. It's now a twin-nested hierarchy where genomic sequence comparisons overlay the original tree that was based on morphology alone and provides additional evidence to confirm or sometimes correct what we could previously only determine from fossils. And this new means of objective verification was a vast improvement, requiring revision of the antiquated 18th century system to update it. It's no longer just 7 taxonomic ranks. There are at least 10 times that many named clades just in your ancestry, from the earliest or most primitive organisms all the way to you. And we're learning more all the time, so that a few years from now, we will have discovered a few more.